Hello. We're gonna do a example in 6.3 area and the definite integral. This is actually a exercise in this section. So we're going to discuss this example in here. The example is to find a approximation of the area of the region under the graph wave. Okay, so this is the curve. Okay, you can see f of f, y equal to f of x. So find an approximation of the area of the region on the graph wave. We want to find the area under the curve, on this curve between x equal to 1 and x equal to 3. Okay. And we do it by computing the Riemann sum of f corresponding to the partition of the interval into the subintervals shown in the figure. Okay, so we partition the integral from 1 to 3 as how many? 1, 2, 3, 4, 5, 6 subintervals. Okay, so correspondingly, we draw 6 rectangles, 1, 2, 3, 4, 5, 6. And the height of the rectangle is from the midpoints of the subinterval. So use the midpoints of the subintervals as the representative points. Okay, so you just pick up the midpoints in each subinterval and from there to draw a vertical line, and that will intersect the graph with the curve in somewhere, and then we use that as the height of each rectangle. Okay, so that's the question, and we need to compute the sum of these 4 rectangles, and we use it to approximate the area under the curve from x equal to 1 to x equal to 3. Okay, so that's the problem. And this section is about the area and the definite integral. So, we use the area to define the definite integral. Okay. But anyway, let's just start this example. So what we need to do is we just calculate the area of each rectangle and add them up. So that's called the Riemann sum. Okay, and the height of each rectangle is marked in the graph. 1.9 for the first rectangle, 1.5 to the next, and so on. So we have all the heights, and then we have the width for each rectangle, and there are subintervals from 1 to 6. So how many subintervals? We have 6. 1, 2, 3, 4, 5, 6, right? 1, 2, 3, 4, 5, 6. 6 subintervals. And then we can find out the width of each subinterval. And we divide the subinterval from 1 to 3 into 6 equal subintervals. So the width of each subinterval is what? So the total length of the interval from 1 to 3 is just 3 minus 1, right? So from 1 to 3, the length is 3 minus 1, which is 2. And we divide it into 6 subintervals, 6 equal parts. So the width of each subinterval is just 3 minus 2 over 6. Okay, so that's the width of each rectangle, basically. So, you know, as I said, 3 minus 1 is 2, 2 over 6. We can simplify it a little bit. If you cancel 2 in the numerator and the denominator, so we got 1 over 3. So that's the width of each regular subinterval, or regular angle. Maybe regular angle is more appropriate. So, so then we can calculate the area of all the regular angles and add them up. So the total area of the 6 regular angles is the following. Okay, so we have to use the next line. So we know the area of a regular angle is the width times height. So the width of each regular angle is 1/3, okay, as we already did. And then we just plug in the height for each rectangle. Okay, so for example, the first rectangle has height 1.9, so we just multiply 1/3 by 1.9. So that's the area of the first rectangle, and then the next rectangle, again, the width is 1/3, and the height is 1.5. All right, and then just keep on doing this. The third rectangle, width 1 over 3, height is 1.8. Okay, so 1.9, 1.5, 1.8, 2.4, 2.7, 2.5. Okay, so just add them up. Okay, 1/3. That's the fourth. 1, 2, 3, fourth rectangle, and the height is 2.4. Okay. And the fifth rectangle, the width is 1/3, and the height is 1.7. All right. So, and then the last one. So again, width is 1/3, and the height is 2.5. Okay, this one. Okay, so we need to move this graph a little bit to the right hand side. Okay, so now we can compute each decimal and sum up, but there's another way to do it. We can factor out 1/3 from each term. So we got 1, 2, 3, 4, 5, 6 terms. Each term has a factor 1/3, so that we can factor out 1/3 from all the terms. Then we have everything 1.9 the heights, okay, inside the parentheses. So plus 1.5 plus 1.8 plus 2.4 plus 2.7 plus 2.5. And this will make the computation is a little to be a little easier in many cases. Okay, so let's see what we get. So that's equal to 1/3 times. So we need to compute all the numbers in here. Let's see what we get. So 1.9 plus 1.5 is 3.4. And then we got what? 1.8. So that's 4.2, and then add 2.4, so that's 6.6. Oh, okay, sorry. Let's do it again. 1.9 plus 1.4 is 3.4. 3.4 plus 1.8 is 5.2. 5.2 plus 2.4 is 7.6, not 6.6. I'm sorry, 7.6 plus 2.7, that's 10.3. 10.3 plus 2.5, so that's 12.8. So, well, that turns out to be a decimal, and that will be equal to, or approximately equal to 4. What? 3 or 4.27, I guess I'm going to write 2.7 instead of 4.3, isn't it? So that's the answer. All right.